I'm Aaron King. I'm the research director here at Foresight Institute, and basically what I'm doing is spearheading this tech tree project. Um, so the general concept, which is like why trees, basically this is like a graphical Wikipedia. We want to, well, aside from playing a lot of Civilization, I want to know a lot about aging, like every single strategy that had ever been done in the field. And I wrote this giant report. And at the end of it, it was just like, it was 160 pages, and I didn't even want to read it. It was just too much. And so it was suggested to turn it into sort of like a tree format and make it have a bunch of concepts that get linked together into a large web. And I got the concept immediately, and it was very easy to create the initial prototype. And it's been really intuitive, and I think it's a very good way of displaying information. So we can link together. Okay, so the core philosophy of what it is that we're doing is twofold. This is a pretty old painting, and it shows Plato and Aristotle talking to each other, and Aristotle has his hand out, and his philosophy generally is that you need to get out there into the world, you need to see what's happening, you need to understand what's going on at the ground level, and feel your way around in order to understand reality. Whereas Plato's pointing to the sky, and the point is like, well, if we're just really smart and we just sit down and think a lot, we can derive everything from like first principles. And the tech trees are built to capture both of these styles of philosophy. So we're going to map out what's happening in the field, what is going on at the ground level, and we're also going to collect everyone's dreams and aspirations. What do they think the field is going towards? What do they want to exist that doesn't exist yet? And we're going to put all that together in a giant web diagram. And this whole project is for 3, possibly more groups of people. The first is new talent and funders who want to get into the field. They don't know what's happening. They don't understand what's going on. They want a really good comprehensive overview of what is the newest stuff, why did this thing not work, what's going on with each of these pieces of technology. It's for scientists who want to know who else is doing stuff that's related to what they're doing, who's working upstream or downstream of them, whose work will impact their work, and who should they be talking to on a regular basis. And for entrepreneurs who want a very similar outlook, where's all the money going, who's working on a company that might be encroaching on theirs or that they can collaborate with in order to make their work a lot easier. And I think that we're going to get there. So as the features of this tech tree is going to be a digital, constantly updated map of technologies, a comprehensive list of all the companies, the labs, the advocacy groups in the entire space. And it's going to require, it'd be nice to have a lot of feedback from domain experts who are in the field, who know what's really happening at the ground level, who can say, oh, that's wrong, that's right, oh, this should be like this instead. We're going to have bottleneck analysis, so where are all the challenges, what's stopping progress, and I think it should be able to be capable of hosting decentralized bounties and crowdfunding efforts, at least a way of focusing effort to places where it can do the most good. So there's a tech tree for longevity, which is pretty comprehensive, but there's also tech trees for these other domains of interest for Foresight, which are also comprehensive. So the leads for those other tech trees I want to mention briefly. Yuaning Feng, he's a postdoc at Northwestern University. He's working on molecular machines. Marina Polyakova, she's at Max Planck Institute. She's working on neurotech. Yingtong Lai, she used to be at Ethereum. She's now at Electric Coin Company. She's spearheading the intelligent cooperation tree. Romain Fontaine at the European Space Agency is spearheading the space tech tree, and I'm spearheading the longevity tech tree, as well as managing the overall project. So these tech trees that people are coming up with are quite different from each other, and that's on purpose, because I wanted to let people have a certain amount of creativity, and then we're going to try to see all the features of these various tech trees and how well they perform, and try to combine anything that's useful from these different tech trees into sort of a unified format. And there might not be one. Maybe every single tech tree has different requirements and needs to look different. But the longevity one is looking really cool. And obviously this is the crowd to talk about that too. So I'm going to briefly go over the structure of what it looks like right now. And we'll use the extracellular matrix page as an example. So on the top, there's going to be advocacy labs and companies, and that's going to be, this is all going to be digital eventually, so it can be scrollable. There's going to be a lot more entities listed, and we'll try to get all of them in there, as well as any page contributors, people who have helped refine the page. It's broken up into 3 main sections. On the top, there's the diagnostic tools that get used in the field. The middle is the mechanism, kind of the logic of what ECM is, and then on the bottom are the interventions. And those are organized based on development process. So the earliest, least developed concepts are on the left, and it goes over to most developed on the right. There's a bunch of coloration here. So blue things are just sort of like general nodes of information, whereas green are things that they want to see happen, but they don't exist yet. And yellow are like the pathologies associated with any particular subnode of the tech tree. So finally, I think that there's, so these things that are tagged with these little, they look like circles at this resolution, but they're hexagons, little white hexagons. Those are going to be the core reasons why aging is negatively impacting something like this. So for instance, extracellular matrix, we have things like senescence, inflammation, UV damage, but these are all upstream causes, right? So they actually are coming from other nodes propagating into the ECM, whereas something like calcification or mineralization of the ECM appears to be a native problem to just the ECM. So if you solved these other things, you'd still have to solve that. It's like a separate independent piece. So we have some really great advisors for the tech tree, Alexander Fedinsev, Reason, Greg Fay, Christine Peterson, and there's a lot of people who have already contributed. Many of them are in this room already, and hopefully there's going to be many more. And I thank you all for your expertise and your kindness, I guess. So generally, what we want to see is for you guys to just write all over these things. If you see something in these tech trees that looks wrong, it probably is, because I definitely do not know everything. So feel free to edit the tech trees around the workshop area with better information, and you can contact me at aaron@foresight.org. I'll try to talk to as many people as possible over the course of this workshop, and I'll hand it back to Allison.